If you've been 3D printing for a bit and you're about to start making wearable props or costumes for your kid, you better get the fit right.
Getting the scale right early can save you a lot of time, filament, money, and reprints.
Exactly. So in this video, we're focusing on scaling and test fitting the Iron Man helmet before we go any further. Stick around and see how it goes.
Hey, what's up guys? I'm Evan.
And I'm Ryan.
Welcome to the Bonding Blueprint.
So in the last episode, we bought the suit files modeled by Walsh 3D. The next step is making the helmet the right size for Evan's head.
Then we'll be doing some fast test prints so we can check how it really fits before printing in the better, more expensive filament.
That's right, this is our first time printing wearable items and we want to get it right. When you're printing toys or desk stuff, scale is mostly optional. If it's a little big or a little small, who really cares? Wearable cosplay is different. Everybody's body is built different.
And I don't want to smash my nose or squeeze my ears until it hurts.
The helmet can look great, but if it pinches, blocks vision, or sits wrong, you're either reprinting parts or you're stuck wearing something very uncomfortable. When it comes to scaling wearable props, you can absolutely do this the manual way. Grab a measuring tape, jot down a few key measurements, and scale the files based on that. That works, and for a lot of people, that's enough.
But that means you have to keep track of all the stuff yourself. And since we're going to be doing this a lot, we've decided to take it a step further and use Armorsmith Designer.
Armorsmith isn't required, but it makes this process easier, especially with a kid who's still growing. It lets us create digital avatars using real body measurements and then scale the 3D parts against that digital avatar instead of guessing.
So when I grow, we can just update my measurements and print new parts when needed.
It's also not just for Evan. You can save different avatars, so when I want to make something for me, it can track and remember my measurements too. All right, so now we're inside of Armorsmith Designer. And what Armorsmith Designer does is it allows you to enter the measurements of the person you're trying to map armor to or props to, and it automatically scales up and down the figure and saves and tracks all of those measurements. So once we're done measuring Evan, we can use this for other projects in the future or making adjustments as he gets bigger, grows. So first things first, there is a whole tutorial. You can come in here and say, create new avatar, and it runs through taking some measurements. But for what we're trying to do, we're just trying to size a helmet for Evan's head. So we don't need to go through all of this. But what we will do is we'll start a new avatar. So we've got Evan's avatar at 10 years old. And now we need to put in the overall height. So let's remeasure that. This chair out of the way.
Bye, chair.
Bye, chair. All right. What do you think? How tall do you think you are?
4'6".
Yes. 4'6"?
Yeah.
Oh, that's just because you remember what we measured last time. So you're at
4'6".
just about 54 inches, which is 4'6". Evan was correct.
Big brain.
So 54 inches. And so as you can see, it scales the figure down. So now this is overall Evan size. And the first thing you want to do is the overall height, because what it does is it scales down all the other parts that are linked to it. And so now all we need to do is kind of really just size the head and maybe the neck. And so I kind of just work top down. Now also you can change the avatar is kind of sitting there with his arms out to the side. Seems a little silly because you wouldn't wear armor walking around like this.
Yeah.
So we can change it to a relaxed pose.
That's
and
still
then,
not relaxed. This is not relaxed.
Well, yeah, but once you have armor on, right, your arms might come out to the side because you're going to have big, thick armor pieces on, and you'll be kind of like, you're going to be walking around like you're all buff.
We'll have to make an Iron Man stands thing for when I'm not using it.
Yeah, exactly. We'll make you one of those big glass cages like Tony Stark has in his office for all of his different Iron Man suits. You make an Iron Man suit a year, and they'd all grow up over time. Oh, and apologies, I'm at the end of a cold, so if I sound nasally or congested, that is why. Oh, hold on. So what you'll need is a tape measure. I have one that has imperial and metric on it because a lot of 3D modeling uses metric. And you're also going to want one of these, just a little tailor's tape measure. The nice thing about this is it's got a little hole on it, so you can kind of put it in here and then push this little button and it ratchets closed around whichever body part you're trying to measure, and gives you the measurement. So that's kind of nice. And then we also printed these calipers. These were originally designed by Uncle Jesse, I believe. And then I grabbed a modified version to not have the text here, but it's a little bit on the loose side. I wish it was a little tighter, but
So
you can at least
put the blue putty on it.
I put blue putty on it to try to stiffen
That
it up
does
a
like
little bit.
nothing.
Didn't do nothing. Didn't do anything. So your nose from nostril to nostril is 1 inch.
Is that big?
I don't know. Seems normal. Your nose seems like a normal size nose. All right, so we'll do head height. So right under the chin. Is that your head or is that your hair?
My head.
Head. And so as long as you hold on to it pretty tight.
8
you
inches.
Put it right on there. It's actually 8. To be precise, 8 1/4. Do you know what a quarter is in decimals? 0.25. All right, so your head height. So we're changing the head height, and we're going to say,
Oh, that
wow.
is not right.
That
is not right.
seems excessive. I don't have a big giant noggin, but maybe because I haven't set the width yet.
You haven't done the chin length.
Yeah, I haven't done any of those things yet. So we just did head height, right? And we'll just click on the head so we can kind of take care of all the head stuff here. And now we want head width and depth. So head width. We'll go, and I don't think this includes the ears. It's what we kind
I'm a
of
big brain.
what we messed with a little bit off camera.
6 1/4.
So 6 1/4. Good. You're learning the measurements. What was this width? So 6 1/4.
6.25.
Your depth.
That looks so big, bro. Push more on the back.
We'll say
8
7.
1/2.
We'll say 7 3/4. And that was the depth. 7 3/4. That's definitely doesn't look right.
That is so fat, bro.
Let's measure. All right, let's see. Did I type in your height wrong? Your overall height wrong? Overall height, 54 inches. That's
I
what
guess
we
that does
measured,
right because
54 inches. Yeah, so the height's correct. Height's correct. It's possible there's other stuff in here that's not measured correctly, but let's measure around your noggin and see. If this
around the
adds
world.
up. Usually right above your ears. Yeah, 22 inches. The head size is correct, but probably what's not is things like your chest. So it's
No,
making
but you
your
click
head
out
look
of it.
extra-
See, it looks different. Click back into it. Click back into the head. It makes it look bigger because the pieces are outlined, but that's probably
Yeah,
on
it's the
3
same,
times.
but it's okay. But when we size the helmet, we're going to need to leave room for some padding here on the sides, right? We're going to need padding on the sides. There'll be some padding because there's going to be some motors at the top of the helmet. We might try to mount a battery pack to it, stuff like that. So we'll be using a couple different things, but those are correct. Those are correct measurements according to this. Now let's see. Let's double check and check your neck.
Check, mic check.
So your neck is pretty much round. So let's just do circumference. Sure, it's just tough with the hoodie on here. Because it's possible we just need to thicken up the rest of the body parts. So that's 11 1/4.
You should give that more.
You want it tight, and then when we put the armor over the top, that's when we leave space for breathing and pinching and movement and stuff like that. You want this to match your body. You don't want to
It's not
start
gonna be
making
perfect,
it a
though.
little bit bigger, a little bit smaller. It's not going to be perfect, but we don't have a 3D scanner, so this is as close as it's going to get. Heads are bigger than our bodies. Here, turn to the side. Let me see. I don't know. That might be right. Hold on. Let's see. Chest. I mean, you put your hoodie on, so this is going to be 20, probably maybe even 29. So let's see. Chest. And so as you can see, right, you can input different dimensions for each body part. So you've got the width, the height, and then the round. What do we say? 29?
29.
Okay. You know what? I mean, that's pretty accurate. So maybe, that's just proportionally sized head. And it looks weird because we're not used to looking at you like a weird mannequin looking thing, right? All right. So why don't you grab a chair and we'll talk a little bit about the next steps. Because now we've measured your head. So now we get to size the helmet first to match your head. All right, so Meshmixer is a free 3D modeling software. It's made by Autodesk. And it's a pretty simple software, but it actually does quite a bit. You can combine different pieces and parts together to form one big object. You can subtract some objects from another object. You can do some minor editing. You can also slice the helmet up into different parts. As you can see, the files that we got here, They're all in kind of different parts. So you can print them separately and then assemble them after the fact. So what I wanted to do first is I wanted to create just a low resolution version of the helmet for scaling purposes. Now there's a lot more parts to the helmet beside on the final when we print the helmet. There's going to be a lot more parts. You saw there was a lot of detail here inside the mask, and this doesn't have that because it's just made for like scaling or test fitting and stuff like that. So when we print the final, we're going to print a lot more parts. There's little screws that go here in these little holes. There's eye covers that will hold the little LED lights for the eyes that he can see through. And there's parts with other details and internals that we're going to print later. But anyway, so in Meshmixer, I combined all of the parts that we need to correctly size it to Evan's noggin. That's right. Okay. And then what I did is I exported that over to or I exported it as an OBJ, which is just a file that goes in between other files, or actually I might have used an STL file. I did use an STL file. So we're going to import that helmet into Armorsmith Designer. All right, so now that we've got the helmet imported into Armorsmith, what we want to do is just take that. You can say, hey, I want to attach this to, like, I can put the helmet on the wrist or the forearm, but obviously we want it on the head. So you can take the helmet. Now, obviously that looks like it's probably a little bit on the larger side, but who knows? So what we can do though is, obviously I need to be able to see how much space is in between Evan's face and the helmet itself. So what we'll do is we'll take the helmet and we're going to make it partially see-through. So with the helmet selected, you can come over here to opacity and we can make it half see-through. Let's actually take it another step. Oops. Take it another step further and let's go there. So now you can actually kind of see how the helmet's going to size up to Evan's head.
Looks pretty good.
Right. Well, and so what you want to do is obviously you need to be able to see out the eye holes, right? So you need to be able to line up the eye holes together. And so what we can do here is we can take the helmet and there's different tools up here. There's move, there's rotate, and there's scale. So move, right? Well, obviously that's, probably makes sense, right?
Yeah.
So once you bring up the move controls, you can move the helmet around and you can see as we hit your face, you can kind of, you can kind of see how it's cutting, it's not matching up. So we're going to kind of just get, probably where the eyes are, right? Is probably the most important thing. You need to be able to see through the eye holes. Now, I think this is probably a little on the big side still, right? Like, I mean, even with padding.
I think we need to open the wide. Well, we still haven't measured my eyes.
You can check that in a sec too. So when you go to the scale tool, there's uniform scale, which, and then there's non-uniform scale and freeform. Examples, right? So uniform scale scales the entire helmet up and down uniformly on all of the different axes. But if you go to non-uniform, what that allows you to do is you can shrink a helmet or an armor piece on just one axis. Right. So if for some reason, like you had a really long head, you could actually make the helmet wider like this direction, but not for the ears. Right.
My
now,
head
obviously,
is so big, bro.
we don't want that. So, and also too, with forward thinking, we've done a lot of research on this. This whole suit is going to be motorized. The helmet's going to lift up. They're going to be lit up. There's going to be servos. Yeah, and there's going to be servos and motors inside the suit to like raise up armor, missile pods, or like all kinds of different things, right? And so if you start non-uniform scaling things, these armor pieces are engineered so they fit together. There's actually little, I guess you don't see it from this view, but there's like little magnet holes that go along here. So the two panels will interact and intersect and magnet together. And if you start non-uniform scaling stuff, it gets a little tricky when you're trying to put motors in the right place and things like that. So for purposes of the helmet, we want to keep this as simple and easy as possible so it can be as successful as possible. We don't want to run into a ton of hurdles that we have to work around for the very first attempt at one of these projects. So now that we're in uniform scale mode, now we can make a little adjustments to the size of the helmet. And we're just going to kind of move it around, knowing here at the top of the helmet, there's also going to be wires. There's going to be a motor with servos here that lifts the mask up. So we need to make sure we're accounting for the stuff that's going to go in the helmet as well as fitting it on Evan's head. Not all cosplay needs to have all these motors and gears and lights and stuff. So what I'm looking at is, right, lining up your eyes so you can see out the mask. Making sure your chin sits just inside this little chin shelf area here. Because we also have to put a button on the inside of the mask for you to be able to trigger with your face. So you might be popping it with the bottom of your chin. You might move your chin off to the side or something like that. Like we got to figure that out. And eventually it'll be voice controlled. But for the first version, a little chin trigger or something I think will be great. So this, I mean, it still feels a little on the big side though. And I worry too, right? We obviously, one of the big things is we want to make sure you get enough room in there for your ears so it's not super, super tight on the sides. I don't know. Do you think smaller maybe still?
No, I think on the ear sides, I think like a little bigger.
You mean wider where the ears are?
Yeah.
Your ears don't stick out a ton. And if they get pushed in just a hair, I don't think it's the end of it. I don't know. Your face seems to fit in the mask fine. I don't think your nose is going to smack the front of the mask.
I think that's pretty
There's
good.
room for the back of your head to get kind of sandwiched in here. And we got a really light battery pack, so this might give her enough room to put the battery pack at the top.
Good.
Yeah, we'll try
Let's
that.
print.
So now we're back in Meshmixer and we've imported the helmet that's been scaled in Armorsmith. And so what we need to do, as Evan just pointed out, the helmet's one solid piece and we don't want to print it in one solid piece. We want to print it in parts. So what we're going to do is come back in here to edit and you're going to say separate shells and it thinks for a hot minute. All right, so now what it's done is it's gone and separated everything out. And when I click on a part, you can see it highlights it in gray. And now you can see all of the parts have been separated back into individual pieces. Okay. So now what we're going to do is we're going to export this. Okay. All right. So we just got back from hockey practice, a little bit more sweaty, but otherwise we sat down. We finally got at least the kind of 4 big helmet parts set up. They're all scaled to, hopefully, Evan said if we did that right. But that's what this is, to figure it out, to see if we are scaling it right, if we're thinking about it properly, and using the software properly. So here we have kind of that top dome of the helmet, and the back plate of the helmet and the chin. And then, of course, the front face mask. Very iconic. Can't forget that. But those 4 parts will be enough to tell us if it's the right size. I don't need to print the ear circles and the little eye cutouts and things like that.
Why not?
Well, for right now, because this isn't the final helmet parts. They're going to be, we're going to be printing them in ASA, right? So these are just kind of, it's a better filament. It's a tougher filament. It's a lot more durable, so it won't be prone to breaking as much. Like PLA, like you saw with your Fortnite crown, right? It kind of, like, we lost parts of it because we didn't print it with thick enough settings. Yeah. So we're going to use a better filament. Plus, ASA is better for sanding. It's easier to sand. It'll be easier for us to paint. So overall, it'll be a better material. We're going to use PLA to start to make sure we're thinking about scaling to Evan's body properly. So these are test prints. We're going to print them at a pretty high quality, though. We're going to do high quality at the layer height 0.16, just to give it a little. I could speed these along, and because they're test prints, I probably should. But I also want to see what the quality looks like with these layer settings at these orientations. I'm guessing. I've watched a few videos of other creators talking about part orientation and things like that and trying to find the best way. These half-seen red blocks, if you don't know, those are support blockers. So those are spots where I don't want supports to generate, and I put them in very specific spots where they were generating for little magnet holes and things, and we don't really need that. So anyway, this is what we're going to try. So we're going to send these off to the printer over the next couple days. And if I come in here and do a preview, we look at all of the stats here. So total print time for all 3 is going to be 1 day, 9 hours. So day and a half. Evan will be back over here tomorrow after school. So we'll take a look at some of the parts then. And then once they get all finished up, we'll kind of tape them together, put it on Evan's head. Okay, real quick in our editing time machine, this back piece right here, this did fail in the orientation I was showing earlier. It lifted up off of the plate before it had a chance to really stick to it, and it was not the right way to orient the part. So I did change the orientation of the part to something more like this. It needed a lot more surface to adhere to the base. So everything else remained pretty much the same, printed successfully, but I just wanted to show you if you're following along and you're planning on doing this yourself, this is the orientation that I had all of the parts in that ended up in successful prints. So while Evan's at school, I pulled the rest of the helmet parts off the printer and started cleaning everything up. The goal was to have the full helmet assembled and ready to try on by the time he got home. I started by removing all the supports and doing a quick cleanup on the edges. Overall, the print quality came out really solid. I added a lot more supports than usual on the top dome, but that area should be easy to fill and sand down to get like a really good smooth surface. The rest of the parts have the usual support marks you'd expect, but nothing surprising. The orientation seemed to pay off and the surface quality came out really nice. This should sand, fill, and polish pretty well, which is exactly what we want for that like metallic Mark VI look. There's a few edges here and there that need some cleanup, but overall I'm really pretty happy with how this turned out. To get a quick test fit, I spot glued on the chin piece, and then I used some gaffer's tape, which doesn't leave a residue, to assemble the bottom lip and the cheek to the helmet. I tried to keep the tape on the loose side for the mask so it would lift up. And then pretty much now the helmet's ready for Evan to try on as soon as he gets home from school. So Evan is seeing the helmet fully put together for the very first time with all of the pieces and parts.
What about that thing?
Yeah, and then that'll go on. This is gonna go on the back once you put the helmet on. So there's all of the pieces. Now careful, because this is just taped. This front piece is just taped, and the mask is kind of loosely taped on there just so it doesn't fall off. That's so cool. That's awesome. All right, let's put this backer on and see. Now this hopefully doesn't pinch your ears and your hair. Let's get it around your ears. And then now this was actually a really tight fit getting this on, and now I've added magnets. It's gonna be a little difficult to do. I wonder if you can fit it on without taking this off. Definitely not something you'll be able to see. I don't know if you can get your head through that. Nope. Here, actually, put that on your head and then hold on to it. Make sure it balances. But look straight at the camera. All right, so we do have to. And once we
maybe you can just like try and like.
Well, once we sand it down and stuff, I think it'll be a little easier to slide in there. And I just have to get better at the process of it. I'm like that useless robot from the Iron Man movie, you know, that can't do anything right and keeps dropping things. All right, that's on. I think I almost wonder if it needs to be bigger. Because it's not gonna sit on your head at the top. It's gonna float a little bit because there's actually gonna be a pad there. So I did get some pads just for testing. Just wanna slide a pad in there because this is probably about as big as the electronics. Yeah, and then
it wobbles.
Well, yeah, but we'll put pads here, right? You'll probably have some cheek pads or ear pads. I think once all the pads are in place, because you'll also have another pad in the back, but that'll probably be, you'll have two pads on the side, the top, and I might have to get bigger pads because I don't know what the bunch of mechanical stuff that goes in the top of the helmet. But you look right out, that looks so cool.
I'll go see it.
Dude, that's so cool. What do you think? Mm-hmm. It's pretty awesome, huh? All right, so for a first prototype, I think it's fitting probably pretty well. Once the padding's actually secured in place and we add all the mechanical parts inside the top of the helmet, I think this is gonna land just about right, especially when we're probably not gonna finish the entire suit until around like Halloween time. It'll give Evan a chance to grow into the helmet a little bit more. What do you think?
Yeah. It actually feels pretty good, and I can see out of it fine. Pretty cool. I like this.
The ears.
The
yeah.
ears.
Yeah.
And like.
Oh, and does it pinch your ears, or is it you good enough room in
No,
there?
it's fine.
Okay, because I know we made it wider when we scaled it, and that feels pretty good.
It looks cool when you look out because you can see this like chin thing.
Yeah. You see the bottom of it and everything. Yeah. Yeah, and I think the pads on the cheeks will probably be good.
And the mask, like, to put it on.
Yeah. So in the next 3D printing journey episode, we're going to be motorizing the prototype helmet, adding LED eyes, and get everything all wired up so the mask opens and works the way it should. So once we know for sure that the fit is solid and the mechanics are working the way that we want, we'll decide how to size the final and print the final parts in ASA, but we'll probably put that off for a little bit. We can even practice painting this and stuff like that, and we'll get it fully motorized. You can eyeball me with the helmet.
If you want to see the helmet come to life, make sure you subscribe to the channel so you don't miss the next episode. See you next time.